In this lesson, we'll talk about finding the slope of a tangent line to a curve. Now let's say we take the function x squared minus 5. Here you can see the curve is drawn, and I picked a tangent where x equals 3 and y equals 4. And I labeled that point A. Now the problem occurs is that I don't know another point on this purple line. And using the slope formula, I will need 2 points. What I can do though is find another point on the curve, which I have labeled B. When x equals 0, y would equal negative 5 for the curve x squared minus 5. What I can do now is draw a line between A and B and calculate the slope of that line. How to do that is I put y2, which is 4, subtract negative 5, which is equivalent to adding 5. I can then take the x value, which is 3, and subtract 0. And of course, that slope would equal 3. 4 plus 5 is 9, divided by 3 is 3. But the problem occurs is when you can see the picture here, the black line is similar to the purple line, but does not have the same slope. We can make even a better approximation. I could go even closer. You can see now that the black line and the purple line are similar, but still not the same. The slope between these 2 points now, again, would be 4 minus negative 1, which is the equivalent of plus 1, and 3 minus 2. And of course, that equals 5 divided by 1, or 5. Now, we can see that 5 is a better approximation of the purple line, but still not close enough. What would be the best if I could get B as close as possible? Let's say here. Well, now if I substitute these in, I can get 4 minus 3.29 as the y value minus the y2 minus y1. And then I can get the x values, 3 minus 2.88. In a sense, rise over run. Now this works out to a value of 5.916 repeating. So again, we can say that 3 was a good approximation, 5 was better, but so far, this 5.9166 is the best. Let's see if we can even do better. What if I moved B as absolutely close as possible as I can? Well, now I can have the slope of the y2 minus the y1 over the x2 minus the x1. Now this gives us a value of 5.999 repeating, which is approximately 6. So we can say with fair certainty that the tangent at this curve is equal to a slope of 6. Now to just confirm that, we should always make an approximation on the other side, where I'll make a point on the other side of A. To check this other side of limit, we can get the y2, so 4 minus 4.24, divided by 3 minus 3.04. And this gives us a value of 6 as well, approximate. So now we can say with quite certainty that the slope of the tangent at A, 3, 4, will have a slope of 6.